Hello, everybody, and welcome, I guess, to class. Anyway, today we're going to learn some pretty neat stuff about divisors, division, prime factorization, greatest common divisors, that sort of thing. So let's go ahead and get started. All right, we're going to start off talking about divisors. So let me grab my pen, and we will talk about divisors. I apologize for my handwriting. It's not good to begin with, and it's even worse in this format, but we'll give it our best shot. Okay, so let's first talk about what it means to divide something. So we use this notion. We say that A divides B means that B is equal to some integer multiple of A, and actually all of these numbers, A, B, N, are going to be integers. So A divides B, yeah, it just means that B is some multiple of A. Okay, easy enough. All right, so let's start off with an example. Let's find the divisors. Find all divisors of 1, 2, 3, 4, 5. All right. Well, we can, best way to approach this for now at least, is just going to be to do some trial and error. So let's think about this. You might know some tricks for knowing divisors. For example, this number here, it ends in a 5. So because it ends in a 5, we know that it is actually divisible by 5. So we can divide by 5. So 5 divides 1, 2, 3, 4, 5. And we know that 1, 2, 3, 4, 5 divided by 5 is, let's see, 2, 2, 3, 4, 20, subtract 3, that's 6. 30, subtract 5, and 9. So we know that 1, 2, 3, 4, 5 is equal to 5 times 2, 4, 6, 9. All right, great. So we know 5 is a divisor. Let's see here. If you add up all the numbers, we have 1 plus 2 plus 3 is 6, plus 4 is 10, plus 5 is 15. 15 is divided by 3, so we actually know this is divided by 3. 3 divides 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5 divided by 3 gives us 4, 1, 1, 5. I did this in my head down here. So that's 1, 2, 3, 4, 5 is equal to 3 times 4, 1, 1, 5. Okay, so maybe we should start making a list here. So the divisors are, well, let's not forget 1. 1 definitely divides 1, 2, 3, 5. And does 2? No. We found out that 3 does, so I'll put that in our list. 4, well, if 2 doesn't, then 4 doesn't. 5 does. Let's see here. What other numbers do we have here? Well, we can get rid of all the even numbers because if 2 doesn't go in, then no other even number does. We should probably try 7. Right? So let's do, how do we tell if it is a divisor? Well, let's divide and see what happens. Divided by 7. 1, 7, 5, 53. 7 goes into 53 7 times. That's 49. Subtract 4. 4, that goes in 6 times. 6 times 7 is 42. Subtract 2. And that doesn't go in evenly, but just to finish the algorithm, that goes 3, 21. Subtract 4. 4 is our remainder. Not equal to 0, so 7 doesn't work. 8 doesn't work. If 3 doesn't go in, then 9 doesn't go in. if 5 doesn't go in, 10 doesn't go in. We can keep going. As an exercise, you might want to finish. Well, we'll keep going. Okay. Let's skip. We know that 3 times 5 equals 15. And if 3 goes in and 5 goes in, then 15 has to go in. And actually now we can finish off our list by taking the partners of each of these. 1 times 1, 2, 3, 4, 5 is 1, 2, 3, 4, 5. Well, we already figured out 3 times 3 is paired up with 4, 1, 1, 5. So 4, 1, 1, 5 must also be a divisor. 4, 1, 1, 5. Okay. And at the same time, 5 was paired up with 2, 4, 6, 9. So 2, 4, 6, 9 must be a divisor. And if we take 15, which we haven't done yet, so let's do 15. 1, 2, 3, 4, 5 divided by 15. Let's see here. 15 goes into 12 no times. 15 goes into 123 a bunch of times. How about 8? 8 times 5 is 40. 8, yeah, it's 120. That worked out nice. 34, so we got 2. That's 30. 30 minus 4 is 45, and that goes in nice even 3 times. All right, so that means that we have 8, 2, 3. All right, so here we have a nice list of our divisors. Whoops, don't want to do that. Let's do it by the box. Tell you what, let's do that. Just draw a box. Okay, so we have our divisors. Great. Now that was kind of laborious, and we're going to learn ways to do this maybe a little bit more systematically, but you get the idea. Basically, we're just looking for numbers that divide in